of the seminar presentation so that we can have a little bit more of an easygoing conversation just amongst you all. So welcome, bienvenue tout le monde. I'm so happy to have you here today. This is a beautiful sunny day where I am coming to you from Waiwaetanong, which is Windsor, the University of Windsor, where we are situated on the traditional territory of Three Fires Confederacy First Nations, where the Ojibwa, the Odawa, and the Potawatomi. I consider myself very, very fortunate to be a director of FishCAST because I get to interact with all the lovely people that we see here from some of our FishCAST PIs. So a big thank you to Margaret and for Kat for being here today. Kendra is our wonderful program coordinator. She is on a much deserved vacation, but she did pop in to make sure everything was going well. And thanks to you all, it is going super well. And it's so lovely to see everybody and some of the trainees coming from Quebec. I see trainees from Ontario, and we have some trainees potentially from Manitoba. Just put your hand up, and if I missed a province, my apologies. Oh, Halifax, Nova Scotia, how can I forgotten? But anyways, it's not just about FishCast trainees that are here present. Our seminar series is now geared towards our FishCast alum. And when this is the second or third season that we've done this to highlight and showcase the successes of our trainees, what they've gone through, where they are now, and just to enjoy learning about their journey and what they went through, and the fact that they're willing to share it with us. A huge, huge thank you. Kat, if you don't mind me putting you on the spot just to give a quick little intro for Ryan, but I will say on my end, Ryan has always been such an integral part to FishCast in terms of being involved in some of the workshops that we've done. Ryan, you were the first one to be part of the TEK team to help us our first time when we were spent in, I think, Rondo Park. And then you carried on that information to the other generation. So really, really thank you. And on a personal note, I didn't know Ryan officially until he actually joined the University of Windsor, but I did know of him indirectly because he helped seed our land to restore it back to tallgrass prairie when he worked for the Essex Regional Conservation Authority. So he knew of my property before I actually really got to know Ryan. So, but I'm so, so pleased to have gotten to know him. I'm going to turn it over to Kat. Sorry, Kat, I really appreciate it. And then turn it over to Ryan himself just to tell us all about his research and what he's doing nowadays. So thank you very much, everybody. And I really, really hope you enjoy the seminar. I'm sure you will, as I know I will.
Great, thank you. I think Lauren might also have some words to share about Ryan, but Ani Buju, kumusta everybody? My name's Catherine, and I have the privilege of being part of the FishCast community since I was invited in from Tina and others. It's a privilege to just bear witness today. I was really just going to come and bring the popcorn and watch Ryan share his knowledge and experiences, but I met Ryan kind of right before COVID, and with just such enthusiasm and passion for Windsor Essex and ecological restoration. And at the time, he was an undergraduate at Trent University, and I know had been working on a number of different roles and projects with IRCA. And everyone knows you meet Ryan, and it has such a magnetic personality and such passion for the natural world that it was just impossible to not find a project that would, match his skills and his gifts. So it's just such a privilege to get to know Ryan through this work. And I'm just so grateful that he's gone on to a sister lab at the University of Waterloo, continuing to share his talents. But, people love working with Ryan. People learn so much by you just literally walk down a street and you learn so much about the world around you hanging out with Ryan. And was always sort of this that represented the spirit of FishCast, like collaborating and coming to this work from this place of wanting to understand the environment and nature and figuring out how to use science in these partnerships in a good way. So I'll just pass it over to Lauren. It's an absolute privilege and a pleasure to know Ryan in the world and to see what he's doing. And yeah, just a really good person as well. So I'll leave it to Lauren, who has maybe more words, but congratulations, Ryan. You're the best. So
Thank you so much for those
I
words,
enjoy this.
Kat. Thank you.
Oh, Kristen raised her hand.
That was an accident. Sorry.
Oh. I won't say too much more, so Ryan can get started. But my first day of fieldwork ever, but also with the lab, was Ryan's first field day for his master's project. And it was my first time meeting anyone from the lab in person. And I just remember it being the best day ever.
Okay.
And that involved like, looking at vegetation in a farm ditch. So that says a lot. But also similar to what Kat said, I spent the rest of the summer working with Ryan and helping with his field work. And the big takeaway is what Ryan's personality is. And he's just a super kind, friendly guy. And he can genuinely make anyone smile, like the grumpiest farmer. And, you know, he's also helped me a lot with my field work as well. And yeah, he was such a delight to have in the lab. And he's just such a warm presence. So, and I know now, he's moved on to being a lead field tech for the Rooney Lab, and I guess we're going to be hearing more about that today, and I'm looking so forward to it. And he just got married, so everybody give him a congrats. Beginning of October. Yeah.
That is the craziest introduction I ever had for a seminar talk. Like, I don't know why we're showering me with all of these compliments. Thank you so much. It's good to see a lot of familiar faces again. I'm excited to reconnect with these familiar faces in FishCAST and give myself another chance to bore all the fish people when I talk about plants. So yeah, let's get into it. My goal for today is really briefly to touch on my academic journey, talk about my experience with FishCAST, and then talk about my current job back in academia as a research technician. By the end of today, every single one of you will know who Hydrilla verticulata is and how incredibly dangerous it is for our wetland environments. And then throughout the presentation, I'll be trying to touch on something that adds more value than just talking about Hydrilla. I was looking at other FishCAST presentations, and the most recent one was like talking about how eDNA work can help you in your career path. And I don't have that advice for you about eDNA. I count plants primarily for a living. So my theme that I really wanted to bring was like the importance of collaboration in environmental research. So I'll be pulling through and connecting that back to a lot of stuff today. So first off, I completed my master's research at the University of Windsor with Catherine Fabria. At GLEAR, I was a member of the Healthy Headwaters Lab, and my research was focused on the vegetational communities within agricultural drainage systems, more specifically drains that have been impacted by the presence of invasive Phragmites australis and Phragmites australis management. My goal was to better understand the vegetational communities that grow in these highly managed landscapes and to further explore the ecosystem services that are provided by drains. If you don't know Windsor-Essex County, drains among farm fields are the most dominant habitat type in our region. And most of our drains are also managed for that invasive Phragmites and is a significant source of the invasive species in the area. But we manage these drains on a variety of timelines from 1 to 5 to never managed drains. So I wanted to look at those variables and other environmental characteristics of these drains to better understand what vegetational communities are in these highly managed systems. So I won't go too deep into my master's research besides a couple highlights. I was only able to actually survey around 600 meters to 800 meters of drainage habitat, which is way less than like 1% of the actual drainage infrastructure in Essex. Despite that, across these surveys, we found 130 different species of plants in these drains, a significant number where I was only expecting to find frag, grass, and maybe a couple aquatic plants. There was a surprising amount of biodiversity from solidagos to asters to dogwoods. There is biodiversity in these drains, and I only was able to find or survey a very small fraction. With that being said, it was nearly a 50-50 split with these plants being introduced or native species, with native species only occupying 56% of the species. So alongside my master's research, I was a FishCAST trainee in cohort 1. I fit under the theme 1 of ecosystem and habitat assessment. I know from firsthand experience, and maybe some other people on this call, there's some crazy fish that we've seen in our agricultural drains, and a lot of the river infrastructure in Windsor beyond that first order or fourth order stream is directly drainage infrastructure. So I connect through the fish and I talk more about the plants, but we're all connected through the water. I consider myself a COVID virtual trainee where a lot of my training and a lot of my virtual or my schooling was actually done during COVID times. Um, and I know a lot of people look back at that time as like different experiences and different like situations that everybody was living in. But FishCAST did provide that opportunity to connect with other trainees at different universities that were doing way cooler research like Arctic salmon, and I was looking at agricultural drains. But in COVID, I was able to talk with those PIs and talk with those trainees. And I do think that some of those events, like the micro-credentials, the seminar series, and the workshops, those were also beneficial to just surviving COVID school. One of the favorite events that I did attend, and Tina actually mentioned this earlier, was the first ever FishCAST field course, a traditional ecological field course hosted at Rondo Provincial Park. And I was luckily enough to be part of the planning committee for this trip. I was mainly organizing the camping component, like organizing who has air mattresses and tents, whose coffee cups can we borrow, where are we going to be cooking food and preparing food. It was a very collaborative effort from people all on FishCAST, the students that attended, and even my mom. We hand wrapped pre-made breakfast wraps before the trip, and then I think a lot of people can attest we survived off of those in some of the camping moments early in the mornings. But I really look back at those events in the FishCAST field camp as a really fond memory. Unfortunately, the photo that I have right there of Ron Sands and Clint talking, that's the only photo I have of that entire weekend. It was so busy that I'm so upset that I don't have more. But yeah, I can't say enough about my experience with FishCAST. So in the seminar title, and like I said, I mentioned the importance of collaboration. And while I'm not like an expert in collaborations, I can't give you that. You can Google the best ways to collaborate and you'll get the 7 C's of collaboration. But like, I'm not trying to give you that today. I'm trying to show you through my experience how collaboration can create really strong and important research projects. So I'm not bringing you advice per se, I'm more of just experience. But my first example of the importance of collaboration, Lauren already mentioned, from my master's thesis, I would not have survived and got even to the small amount of drains that I got to without the helping hands of my lab mates. Convincing people to sit on the side of the road in the heat, get covered in bugs just to count plants was not the easiest thing to do. But part of that grad school experience and part of like our lab culture was to collaborate with each other, work on each other's projects. Somebody will look at your methods. Can you look at her conference poster? That's a really big part of grad school that I really do think is important. And additionally, I had the blessing of helping them with their hard field work. So there's an undergrad in the picture on the left that I helped auger agricultural field, like cornfield, like just for dirt. I had to auger a meter down in like the middle of the summer, covered in corn. And then for Lauren's field work, since she spent so much time in my drains, I could only oblige by helping with mussel research. And those mussel research projects are some like the best examples of collaboration that I can think of, especially when you have university institutions working with conservation authorities, but also federal departments and teams from the Federal Conservation Authority or jurisdictions, and all of them working together to better understand or better protect our critically endangered freshwater mussels. So there are so many examples of collaborations, and I hope I don't annoy you with how many times I bring it up, but also I do believe that collaboration is the only reason why we found hydrilla, and I'll expand on that in a minute. So last year, right before the start of field season in April, I joined the Waterloo Wetland Lab as a research technician. From 2020 till early 2024, I was in Kat's lab either as a student or as a research tech. And in early 24, I was also working 2 more part-time jobs at the Conservation Authority and the City of Windsor Ojibwe Park. And just through the power of the universe, I guess, or just the power of close circles and, as Kat said, sister labs. One of the Waterloo Wetland Lab's PhD students recently graduated, joined the Healthy Headwaters Lab as a postdoc, and I got to meet her through virtual school and virtual meetings. And from those meetings, it just came up that I was looking to move towards Waterloo, and she recommended her lab and reach out and say Courtney recommended. And within the next few months, right before field season started, it was kind of a scramble, but I joined the lab. And like I literally said, on my first day, I was in the field because the day prior to me starting, one of our major frag sites had burnt to the ground from what we assume was a cigarette thrown out a window. But ever since that day, I've been able to participate in a variety of field work across different research projects. A significant amount of my time is spent in Phragmites, but some of the Phragmites work that we do is really cool. For example, some of the projects that we've had in Long Point for Phragmites control has been looking at research and monitoring the treatment of Phragmites over the last 10 years. So you can only imagine how many collaborative papers over those 10 years that Dr. Rooney, you could actually go look at Dr. Rooney's Web of Science to see all of the students that have passed through and have passed on their data to the next chapter, and to now where we're almost done with Phragmites and Long Point. For the Waterloo Wetland Lab, that's a big thing. But it is a really strong example of where collaboration has been so pivotal for some very important research projects. We also have research in stormwater ponds, directly partnering with developers and municipalities to better understand these urban environments. And the last example of a project that is full of collaboration is our new duckweed project, looking at how duckweed is impacting our aquatic environments. This project is crazy, and to start, it's creating limno corrals in a pond full of duckweed. So it's very hard to get rid of the duckweed. You become one with the duckweed after this field work. But more specifically, we have multiple PIs, supervisors, and multiple students, and many of which are all taking small components of this larger project. Someone is looking at how light penetration is impacted by an abundance of duckweed. Others are analyzing water, biofilm, and duckweed for nutrients. And another lab is collecting gas flux information on how methane emissions are being impacted, or how all of these things are working together. So I give these as examples, but I also want to say that I think we're really blessed to be in this field of research. I do think in itself, environmental research has to be collaborative. And I feel like there's other research fields that don't have the same style of environmental or ecosystem research restoration. All of the other, or some examples of other research sometimes feels more transactional, where in environmental fieldwork, it seems like we're all working towards a common cause. So we're trying to understand duckweed, but nobody can collect that amount of data by themselves. So let's divide it into 4 different groups and 4 different undergrad thesis students. So the biggest thing that I think that we've been working on, and the other component of the seminar title, is talking about Hillman Marsh and hydrilla. So if you don't know where Hillman Marsh is, it's a wonderful marsh right up north of Point Pelee. This marsh has gone through a significant amount of stressors over time, and most recently we can attribute it to climate change and changing ice and wave levels in Lake Erie, but the barrier breach on the Erie side has completely broken and breached since 2019. This is creating a lot of issues in the area as it pertains to like flooding. There's a significant amount of ecosystem that has been lost because it now behaves. It used to be a barrier protected wetland, and now it's just a bay of Lake Erie. So there's a significant amount of restoration work that needs to happen, and there are so many stressors that are happening around Hillman Marsh that we need to understand. So 3 months after leaving the Healthy Headwaters Lab, myself and another Waterloo Wetland Lab technician came back to Windsor, Essex, because we were invited to do a Hillman on-site meeting, talking with HHL, IRCA staff, and specifically talking about having conversations and goals for future collaborations, or what variables does IRCA need to look at? What variables is important for CATS research? We got there on site and we were just planning to meet there. It was a gathering of a bunch of different individuals with different expertise and focuses. And we were the focus on the plants. So we went down, and our thoughts for Hillman Marsh were, if restoration is happening in the nearby future, let's try to get some information on the communities that are in the potential restoration zone so we can figure out what is still there and what is in the disturbed marsh. We spent a few days surveying the submerged aquatic vegetation, finding very little and primarily introduced species. However, when we finished the week and our other technician had to go home, I really did think that we could collect a little bit more data in the wetland cells and use those as a potential restoration target. I also didn't want to go home and go back to Rebecca and say, I only found sago pondweed and then 4 other invasive species. So I wanted to go, and I knew that there was bladderworts, and I knew that there were other invasives in the cells, but we just wanted to check. And the only way I could do that is if I went out with another person. So I hit up my friend Amesh from the Healthy Headwaters Lab. He had been doing a lot of YSI work and a lot of sampling throughout the region. So I said, do you want to just come help me be my extra body, and then we can just get some extra data for you for the restoration and what's in the wetland cells. So Amesh came out with me, and we were doing a bunch of sampling. And then on the very last site on the western cell of Hillman Marsh, Amesh caught up to me with 2 plants in my hand, and I said, I don't think this is very good. That was the very first sighting of me and Amesh pulling out this rake. I had literally just gone because I didn't want to throw my kayak in. I went to the side with waders and was throwing the rake maybe 3 feet away, maybe 4 feet, and we pulled up Alodia and Hydrilla within the same rake pull. So I knew immediately there was something different, and this was the first recording in all of Canada. With that being said, there was and there has been recordings all across the Great Lakes along the American side. I'll get it a little bit to more like the history of the plant in a second, but this was the first sighting in Canada. Michigan had one in 2023. Ohio's had it since 2019. New York started getting it in 2020. There's a pattern of it slowly creeping up throughout the United States, starting in Florida in like the 1950s. So within the next few days, we had found hydrilla, confirmed it internally, sent it to the MNRF. MNRF sent a team out to Hillman Marsh, which wasn't that far because it's the Wheatley office and Hillman Marsh is right there, but still, props to them. IRCA was notified, and we had confirmed that with everybody, we have an issue. So within the first 5 days, everybody was like, okay, alarm bells are going off. News releases, creation of warning signs, the closing of the cell all happened within the next few weeks. And then for IRCA, I know from that point on, we were there looking for a restoration project and looking for data, but then I kind of just gave them a terrible invasive species. Here, you have to deal with this now. So I feel bad for IRCA, but they spent the next like 2 or 3 months getting management options available, looking for permitting options for what way to manage and what herbicide we need to use. Contractor hiring bids that were put out. And then for us, we were also looking through decontamination protocols. Like, where can we find, like, what do we have to do to decontaminate our gear? And then within the first 4 months, we had had a full SAB survey done of the West Cell, the creation of maps of hotspots and sharing data with the Invasive Species Center, MNRF, IRCA, and then the first treatment also happened within the first 4 months. So for a pesticide that, or a herbicide, sorry, that hadn't been used in Canada, I think it'd been used in Ontario once, there was a lot of work that IRCA had to do, but a lot of collaboration between the Invasive Species Center, IRCA, MNRF, actual members of parliament trying to convince people like this needs to happen now. It was a good start to the year, and within 4 months we were tackling this problem already. And so why is it a problem? If you don't already know about hydrilla, you will know about hydrilla now. We estimate that we found hydrilla in either the 2nd or 3rd growing season. Typically, if they come from a small fragment or are established through some sort of way, it'll have a smaller population. There's not many instances of multiple fragments entering as a new invasive species. What we found was that it was everywhere, and that the rate that hydrilla had grown when we were going, so we had seen hydrilla in July, and when we got back in October, these are the photos that you're seeing. We knew that if hydrilla had been there longer, it would have completely dominated the marsh within the first couple of years. But since we caught it in July and then saw it in a full growth year, was nearly in every single spot of the marsh, and it was a really eye-opening experience because I had been there in July and I had seen open water. And then when we got back to some of these coves and open, like meter deep open water, there's hydrilla plants pushing itself out of the water and killing other parts of the plant. So it's rapidly growing, and I'll get a little bit more into that now. It is considered the perfect invasive species. So it grows in pretty much any condition at any depth. And it can grow, estimations are crazy, but 2.5 centimeters and create multiple branches off of those other branches within a day. When we are coming back, we've been doing almost like monthly visits throughout the year this year. The first time that we really saw hydrilla, it had 3 branches. The next month we saw it had 9. Then the next month it had 36. So it expands and rapidly, exponentially expands and creates these massive mats that you saw in those last photos. Another huge part that makes it a perfect invasive plant is that there's multiple vectors of spread. So the classic aquatic submersive plant, if you fragment, if you cut it up with your boat motor, you're making more plants. That's very true for hydrilla. Very little plant material needs to be there for a new plant to grow. Additionally, auxiliary turions and subterranean turions, also known as tubers, are one of the worst components of this plant, which make it so easily spreadable. So the turions are growing on the sides of leaf margins, in the middles of branches. It's on the top of the plant where it's growing, and this can produce like hundreds to thousands of turions per plant. So crazy estimations of growth, crazy estimations of reproductive or overwintering bud creation. Those turions can only live for a year. So there's like hundreds and hundreds of them floating around the entire marsh. The tubers are a little bit more like a potato, and like these guys can survive up to 7 years in aquatic sediment. So one of the biggest challenges for places like Florida that has had hydrilla for 50, 70 years is that there's such a big tuber base already built in. So this is one of the major components that like is the driving force and the driving reason why we need to hit it right now. If that tuber base develops, it is just going to continuously refresh every single year. So this is why addressing and talking about hydrilla and collaborating with other individuals about hydrilla is so crucial right now. So after we found hydrilla, like I said, we started reaching out to different places. Florida and the Army Corps of Engineers at the University of Florida has, like I said, like 70 or 60 years of treatment and fighting against hydrilla. So we originally reached out to them and asked for resources, and they directed us to New York because New York is dealing with its very own expansion of hydrilla. So they have spent a significant amount of money looking into research and looking into more northern areas of hydrilla. I didn't even detail that there's 2 different types of hydrilla. There's a monoecious and a dioecious type of hydrilla. So it's like a complete different, it's a different plant in the south than it is in the north of North America. So there's so many challenges that we need to communicate with other people around the area. So we were talking with people from Florida. This year, things kind of changed, so we haven't been in much contact with people from Florida, but there's other instances like the University of Michigan and the Department of Transportation and Parks at in Michigan. They provided a full detailed decontamination protocol. Um, we also helped host, IRCA invited us to do a hydrilla workshop back at Hillman Marsh, a 1-day workshop where we invited Parks Canada, like Point Pelee people who are going to be seeing hydrilla because it's right in their neighbor's yard, and anglers, the Federation of Anglers and Hunters, MNRF staff. Everybody came down so we could show you hydrilla and elodia and just talk about invasive species and talk about wiping our canoe down with bleach, and is that worth it? Can we just dry it out for 14 days? And additionally, alongside like all of this stuff happening in the background, this year the Invasive Species Center funded 3 positions for newly graduated students or potentially still students in undergraduate degrees that are just, their role this summer was to help us like train them in hydrilla, and then they were sent to look for hydrilla in other parts of Essex County. So there's so many collaborative efforts here, specifically talking about invasive hydrilla, where I'm just so happy and so honored to be a part of this and helping with this effort. So before we finish talking about hydrilla and kind of transition back into collaboration a little bit, I just wanted to spend some actual time talking about the two that you are going to see. So hydrilla looks a lot like Elodia, and Elodia is our native water weed. It's really great. It never overcompetes. It's always in its range, and like there could be some clusters that are annoying, but we generally like Elodia. Um, Between the two, like if you're just looking at them, you can hopefully automatically see that hydrilla has serrated leaf margins. It also more commonly has whorls of 5. I know I've seen whorls of 3 on hydrilla, but Elodia is usually a lot more focused on the smooth leaf margins and very tight whorls of 3. Hydrilla is a little bit longer, and I say like if it's scary looking, if the leaves are scary, it's the scary one, and if it's nice and smooth and it looks like just like an not scary and serrated, it's usually generally Elodia. But please, that big feature when looking at it, because now if you are driving or floating by Elodia next year, you might be like, I got to check that for hydrilla. The major way is the leaf margins there, and just shouting out like the invasive species center, invasive maps. Like if you find this stuff, please make sure that you report it. And yeah, the rapid response that we had was so lucky that we caught it when it was. So I'm hoping that you do not see hydrilla, but like I've seen and shown you those photos, hydrilla has the capability to grow so quick. And if we are looking for hydrilla, hopefully we find it at the same circumstance where we're right on top of it. Because right now we're fine, but I'll knock on wood for everybody here. Going back to collaboration, like I said, I don't have the experience that is creating collaborative research projects. I've had the honor and the privilege to join on to that 10-year Long Point research program. So I'm lucky to join these, but I don't have that experience of creating these collaborative projects. So this is also where I love seminars because we did have time to talk afterwards. So asking PIs and other individuals, even trainees, if you have examples of what starts a collaboration. Like I know that everybody identified that Long Point is having a Phragmites issue, and they all came together in a collaborative effort. You spray it, we'll look at the plants afterwards. That I understand that, but like what can we do to create these new collaborations? How do we create more collaborativity, more collaboratively? And then where can we create incentives to collaborate more, or where are those successes stories? Those are the things that I kind of wanted to talk about later in the seminar because I do think that I might not have the experience. I only have the pleasure of like the benefit of working on these collaborations, but you as trainees or PIs might know. Um, Additionally, I do think that I could maybe give you a list of traits that I find are the most important during collaboration, specifically patience and time management. For that duckweed project, we had arrived, and another team doing the gas flux, which takes like 6 hours to do, had forgotten to let us know that they were planning to go that day. So we arrived for our drive for a 2 hour like drive down to London. And then we had to wait for 6 hours to put our YSI in the water for 45 minutes. So just being patient, focusing on time management. We know now, like we won't go on the same days as the gas people will go. That's 100% certain. Communication was also super important. Establishing like clear lines. I really do think the duckweed project forcing everybody onto WhatsApp was annoying because like our lab talks on Slack a little bit more, but having a central role of like you guys check into the exact same chat every single day, who's on site, I do think that is such an important part. And communication also comes into like the lower things of like a positive attitude and common goals. Communication works into a lot of things, but additionally, conflict resolution and flexibility, like I said, collaborating on projects, your schedules may not line up perfectly. So take those and try to figure out a time that works. Um, a more specific like example that I would say is, or a thing that I definitely would recommend is identifying roles really quickly and like making sure that people know like they're the biofilm people. Those people are going to be collecting YSI, and then have like discussion of responsibility for those roles with deadlines. It's just a little bit, oh, I included presentation title there. I just noticed that. Um, Deadlines are so important because, for example, this duckweed project I keep on mentioning, everybody has the deadline for a meeting on December, like at the first week of December before everybody goes away. We're going to hopefully have all of our data ready to go for December so that those 499 students can then write their undergraduate thesis into the spring and get those things done. So, um, with that being said, I don't know how much time I have left and how much time you want to talk about, but um, I do I could give advice about career stuff in the talk afterwards, or just like I said, I do want to talk about collaborations with PIs and like how can we foster more of those collaborations in the future. So thank you all for listening, and I'm looking forward to collaborating with all of you. And hopefully you all know what hydrilla looks like now. So I hope you don't see it, but make sure you report it if you do.
That was really great, Ryan. Thank you so much. I'm gonna pass it over to Lauren. She's is our organizer. You're gonna be guiding everyone. I'm going to stop the recording. I've got a button that says end event. When I do that, I might disconnect everybody. I don't know because Kendra's not here to hold my hand. If I do that, please come back in. This is not the end of it. This is where I want you all to have an amazing discussion. So I'm going to click the button. Okay.
Okay, we're still here.